Hey folks, this is the tutorial walkthrough of the Kubernetes Essentials talk from DevWeek 2024. My name is RHEL. I'm going to do a walkthrough using Linux in this example, specifically RHEL. And so this is found on my GitHub, github.com/RayLahano slash Kubernetes dash essentials dash DevWeek here. As you can see here, we have already have a video walkthrough on Mac OS, and this, like I said before, will be on RHEL. So first I'm going to log into my virtual machine here. And so this is a fresh VM here, so I'm going to log in. And in this tutorial, we're going to install the prereqs, which is a local Kubernetes cluster, in this case Minikube, and we'll install the Minikube prereqs, which is Docker. Then we'll install Minikube, then we'll create a Kubernetes cluster using Minikube. We'll take a look at the cluster, then we'll deploy a containerized application in a pod. Then we'll also deploy the same but older version of the containerized application in a deployment. Then we're going to update that application. Then we will scale it up and down. Then we'll expose the application with a service to the outside. And then we'll do some cleanup towards the end. But let's take a look at some prereqs here. For Minikube, you do need 2 CPUs, 2 gigs of memory, 20 gigs of disk space. We probably don't need that much, and an internet connection. You also need a container runtime. In this case, we're going to use Docker. So let's go into the Docker install here. I have instructions, multiple ways to install Docker on Mac OS, Windows. There's several ways as well but we're going to use the package manager way. So this example here, I'm using yum. Of course, this is RHEL. So let's install some dependencies first. This will take a few minutes here, so just bear with me on this. And then after this is finished, we're going to add the Docker repository. I'm just going to copy this. All right, and let's update our system here. And after this, we're going to install the Docker Community Edition. Of course, the CM update will take a few minutes. That's done. Let's install Docker Community Edition here. I'm gonna get ready for the next step, which is to start the Docker service and also enable the service to start on reboots. All right, so after the Docker service is up, we're going to add our user to the Docker group. And let's activate the changes to the Docker group. And let's test out Docker version. Cool. Docker is running. So we're going to clear this up here. The next step is to install Minikube. So we're going to install Minikube using the binaries on here for x86. So let's copy and paste this curl command here. And get the next step ready. So we'll install Minikube at user local bin. All right, so Minikube is installed. So Minikube is really easy to start a cluster, and we just have to run minikube start. So let's do that. All right. It's downloading the images here. So this will take a few minutes since it's the first time running. I'm gonna get ready for the next step. So with Minikube, we will use kubectl, which is a command line tool for Kubernetes, but we're gonna use the kubectl bundled with Minikube. So we're gonna prefix the kubectl command with Minikube. So we're gonna, after this is finished running our cluster, we will do Minikube kubectl get nodes. And as you see here, Minikube, since this is your first time running kubectl with Minikube, the first time using it, we will see Minikube downloading the kubectl using the correct OS and architecture I need. So, all right, Minikube is up and running. Let's go clear this up, and let's do Minikube kubectl get nodes. Perfect. So, cluster is up and ready. So let's take a look at the cluster. Let's do Minikube kubectl get pods. And so since we did not supply a namespace, it used the default namespace. So let's take a look at the namespaces. Kubectl. Let's do get namespaces. So with kubectl, and I'll show this off a little bit here. Sometimes if you use an option, we didn't do it in this example. It will actually, the format to use in kubectl is a little bit different with using Minikube. This example here, so we have these namespaces, and let's take a look at all namespaces, or let's get pods from all namespaces. So typically, if you use kubectl, you would just do get pods -- all namespaces. In this case, it doesn't work because with Minikube, since we're using an option, we have to actually use a different format. So Minikube kubectl -- get pods all namespaces. So we will mostly use the -- after kubectl from now on. So now we see several pods here we're using for our control plane. We have the API server, etcd core DNS, the controller manager, and also the scheduler as well. So let's create a pod for our application. But first, let's create a namespace for that for our resources. So let's do Minikube kubectl create namespace, my namespace. So namespace is created. So there's multiple ways to run a pod or to create a pod. We will first do the imperative way, which means that we are using a command to create a pod. Later on, we'll do the declarative way, which we will create a manifest for the pod. So let's go and create a pod using the imperative way. So we'll do Minikube kubectl -- run, and the name of the pod is nginx, and the image we're going to use is nginx, and the tag is 1.25.4. We're going to put it create this in our my namespace that we've created, and we're going to expose port 80 of the pod. So our pod is up and ready. Let's take a look. We can check the status of the pod, and let's do it with the -o wide option, so we get the virtual IP as well. So let's do Minikube kubectl get pods namespace, my namespace, and -o wide. So we see this pod has a virtual IP of 10.244.0.3. So let's check out the logs of the pod. So let's try do minikube kubectl dash logs and the pod name nginx. In this case, there's only one container in this pod, so we don't have to supply the container name. If you do have multiple containers in the pod, you have to add in the -c and add in the container name. But in this case, we don't need to do that. But we do need to say this is in the my namespace. And we can see the logs of the pod or of this container. And this is from standard out. So we can see nginx 1.25.4 is running. So now we're going to delete this pod. We're going to do some cleanup here because we're going to deploy this pod in a declarative way. So we're going to do minikube kubectl delete pod nginx -n my namespace pod nginx deleted. So now let's create a manifest so we can deploy this pod in a declarative way. So we're going to use HereDoc to create this file here. So this is a pod, and give it the name nginx, and in the my namespace, we're going to give a label app equals nginx, and this only has one container. And we're going to call the container nginx using the image nginx 1.25.4 and exposing port 80. So we're going to use the apply command. So you could also use the create command to apply the configuration to the cluster. The difference is that with the apply command, if the object is already existing, the create command will error out. So in this case, most folks use the apply command. We'll use minikube kubectl -h apply and the file name. Now we see the nginx pod has been created. Let's check the status of the pod once again. So this is a new pod. We'll do minikube kubectl -h get pods, and in now this case we'll use the short option instead of -h namespace. We'll just do -n my namespace wide, and we'll see this is on 10.244.0.4, and this is about 24 seconds old. So let's once again do some cleanup. Let's delete this pod. Minikube kubectl -h delete pod nginx -n my namespace. Pod is deleted, and we're going to now deploy the same app with a deployment. We're going to do this with a deployment that has 2 replicas of the same pod, and we're going to actually start off using an older version of the application so we can update it later. So let's use HereDoc once again to create this manifest. This is for a kind deployment with the name of deployment nginx and the my namespace. The label of the deployment's app equals nginx. In the deployment spec, we're saying there's 2 replicas of the identical pod. And this first, let's go to pod templates here. And that means all the pods will have a label app equals nginx, and this selector or this label selector means that this deployment will manage all pods in this namespace with the label app equals nginx. Then in this pod template, back to this pod template once again, the pod spec will just under containers. There's only one container. We'll use an older version 1.25.1 of nginx, and we'll also expose port 80. So once that's been created, we'll use the kubectl apply again to create this deployment. Our deployment is ready, and we could use the kubectl get all command. So let's clean this up first. The get all command does not get all the resources, but the majority of the common types, like the deployment, the replica set, and the pod. Kubectl -get all, and in the my namespace, we can see our deployments here. And it's called Nginx, and we can see the replica set here called Nginx, and there's a hash, and then the pods. We can see the Nginx we using the replica set hash and its own hash at the end here. So I'm going to take a look into this deployment using the describe command. And a kubectl -- describe deployment Nginx, and in the my namespace, and we're going to take a look at a few things here. First, you want to point out the old replica set is none, and the new replica set, of course, it's that matching the replica set that we have. And also take a look at the rolling update strategy from the 25% max unavailable, 25% max surge. Now we're going to describe the replica set. We're going to go clear this up, and we're going to use some JSON path as well to make it easier to get that replica set name. Minikube kubectl describe rs, which is for the short name for replica set, and we're going to use this JSON path here using .metadata.name to pull that replica set name, since there is a hash at the end. And in the my namespace, and so here, name replica set is Nginx and this hash. I want you to take a look at, as well as just some events that associated with this replica set, how it created 2 pods that's listed here. All right, so we're going to update the this image and that we're in our deployment in a newer version. So let's clear this up. And we're going to there's 2 ways to update an image. Primarily, most folks will update the manifests, of course, or and then do apply to update the image. But there's an imperative command as well called set image. So we're going to use set image to update the image. So we're going to do minikube kubectl - set image for the deployment called Nginx, and we will. In the deployments, there's a container we have called Nginx, and that container Nginx will be now use the Nginx 1.25.4 container image in the my namespace. I'm going to get the next step ready because it's cool to see if you catch this fast enough with the minikube kubectl get all that we could see both replica sets. And all the pods, or in this case, we see 3 pods. So we see 1 pod creating. We could take a look again. So now we only have 2 pods creating. So let's go back here and to review this. Our first kubectl get all. We see a pod that was creating here, a new pod. It looks like these 2 pods have been terminated because we don't see them again. And when we ran it again for the for this next second time we run kubectl get all, we still see both replica sets in their both runs here. We see one started after 1 second. We see, and then we have our older one as well. It's been going on for 3 minutes. And in the last run of get all, we see our old replica set having 2 pods, or 0 pods, and then we have our new one having the desired 2 pods. And let's take a look at the deployment again with the describe command. Clear this up. So now let's see, the old replica sets now is filled in with the old replica set, and the new one is the newer one, of course. Of course, you can see the events associated with the pods when it's been scaled up and down as well when we updated the image. All right, so next, let's scale this deployment to 3 replicas. Let's say your application has more use or more users. So we want to, let's scale this application up. So you could do this in a few ways. One way is an imperative way, which we're going to do. You could also update the manifest, or you could use the horizontal pod autoscaler. And that's kind of, so the horizontal pod autoscaler, which will scale your application up and down depending on metrics like CPU and memory usage. So in this case, we're going to clear this up, and we're going to now use this scale command to scale this deployment to three replicas from 2. Minikube kubectl -s scale deployment nginx replicas equals 3, and in the my namespace. So that has been scaled up. Let's check out the pods just to make sure. Minikube kubectl get pods, and in the my namespace. So we have 3 pods running. One is fairly new, 14 seconds. Now let's do the opposite. Let's scale it down. Let's say you have less users using your application. So let's scale our application down. Because equals 1. And that has been scaled. And we could also check to see verify the pods as well. See only 1 pod running. So we have our application, and right now it's not accessible to the outside world. So let's make this application accessible to the outside world. So we're going to use a service to abstract from the application and expose it. We're going to use a node port type of service to expose this our application on port 30,000 to 32, I think 686 or 787. So we'll use a service, and there's a few ways to create a service as well. You could also use the kubectl expose command, which is the imperative way to create a service. But in this example, we're going to create a manifest for the service. And this to deploy a service in a declarative way. So you're going to use here doc to create a service.yaml manifest, and we're going to call it nginx-service in the my namespace, and then this label selector app equals nginx, meaning that any pods with the label app equals nginx and then my namespace will be abstracted and exposed by this service. This service is a type node port, like I mentioned, so it'll be exposed on the nodes of the cluster on a port ranges from 30,000 to 32, I think 686 or 32,787. And it will expose the service on port 8080 of the service and send traffic to port 80 in the pod. So let's create that file. So now let's use a apply command once again. Service is created. So let's check out the service. We're going to use the get service, and we're going to use the -o wide option as well. Minikube kubectl get service oy, and of course the my namespace, and we see this nginx-service. It's a node port type of service. It also has an internal virtual IP of 10.110.6.115, and it exposes service on port 31,119 out externally. Will direct traffic to port 880 of that service. And the label selector, which you see here, is app equals nginx. So let's take a look to see or make sure that our lone running pod is the right endpoint for this service. So let's take a look at this pod again. So minikube kubectl get pods, and in the my namespace o wide. So we are having 10.244.0.7. So let's check out the endpoints. Minikube kubectl get endpoints, and the my namespace, and we see the endpoints is for the nginx service, and that is to the 10.44.0.7, and that's correct. That's a lone pod that's running on port 80. So let's clear this up, and then we have this service running. So let's test it out. So typically we could just curl the the localhost on ports or the on the virtual IP. Let's take a look to see. Minikube has some. See, let's get the service again. Okay. Actually, let's try it on port 31. So let's do curl. So this actually didn't work because with Minikube we actually have to do a port forward. So typically on a other type of Kubernetes clusters like a kubeadm cluster, you don't need to do this port forward. But it's with Minikube, so we have to do one more step here in order for to abstract our service. So we do use a port forward command, or which is a kubectl command. So we'll do minikube kubectl dash port dash forward, and that supports to the service nginx service, and we are going to port forward 780 to 8080, and in the my namespace run in the background. I'm gonna hit Control C to keep it running in the background. Then we'll do the same curl command, localhost, and this time to port 7080. And we'll just get the first 4 lines. So now we're able to reach our application. So you've successfully walked through this tutorial, and thank you very much for your time. You've created a cluster using Minikube, installed the prereqs like Docker. If you've deployed a containerized app in a pod and a deployment and updated that application, you've scaled it up and down. You've also exposed the app with the service to outside the cluster as well. So last step is the cleanup step here. So we could do Minikube delete dash dash all, and we're all finished here. So this finishes up Minikube. Want to thank the viewers. Thank you very much for your time, and I will see you around.